In this video, we're going to be talking about transformations, and I can't stress enough how important transformations is going to be to you in the rest of this class and in classes to come. But a transformation is simply a change. A transformation changes the position or the size of a figure. Transformations can be applied to any parent function. Now, in the previous video, we talked about your parent functions. Talked about absolute value functions, linear functions, quadratic functions, square root functions. These transformations can be applied to every one of those functions. And that's the reason it makes it so important. That's the reason that it's so vital that we understand these different transformations. It says use the absolute value function as an example. So what we're going to do, we're going to take y equals the absolute value of x, and we're going to graph it, and we're going to study. We're going to see, okay, down here, what happens when I add 2, subtract 2 from x's? What happens when I add 2 and subtract 2 from the functions? When I multiply, how does that change my graph? So let's start out by taking, and I'm going to graph the absolute value of x for you. And if you don't remember, an absolute value graph is a V-shaped graph. Now, what we're going to do, it says use a calculator, graph the following functions, then compare it to the parent function. So here's our parent function up top. We know what it looks like. It says use your calculator. What I'm going to do, I'm going to use Desmos to make this much easier on us. It says compare it to the parent function and give a brief description. So let's see what happens when I change my absolute value x to the absolute value of x plus 2. So let's switch over to Desmos and take a look at this. Okay, here we see a picture of, again, y equals absolute value of x. I've taken and I've graphed it on Desmos, and I've also got my other equation in here, and let's click on it and see. And you can see what happens. My graph actually, it's identical. It just got shifted over. And let's see, let's change that value, that plus sign. Let me move my graph up a little bit. And what if we change that plus 2 to a plus 3? Or a plus 4, or a plus 5, or a plus 6. You see the exact same trend happening. So that plus 2 took my original graph and it shifted it. So let's go back. When you take x and you add 2 to it inside those absolute value bars, it moved it left 2. Now let's see what happens when I subtract 2. Is it exactly what we think is going to happen? I don't know. Let's check and see. Okay, going back, and here is, again, my original absolute value function. Now, what happens when I do the absolute value of x minus 2? So I've got a minus 2 inside of there. I click on it and show it, and exactly, it moves it to the right 2. And you can check the other numbers. You can subtract 3, you can subtract 4, subtract 5, and exactly what we think is going to happen happens. That minus 2 actually takes your graph and shifts it to the right 2. Okay, on the next couple, we have the absolute value of x and then plus 2 on the outside. Now, here's the difference. In these problems, the plus 2 and the minus 2 were located inside of the function. When I say inside of the function is the absolute value bars. So it's inside with the x a lot of times is what I'll say. The x is inside of those bars, and the plus 2 and minus 2 is as well. And that's shifted my graph left and right. Now here, this plus 2 is not inside of the function. Here's the function over here, absolute value of x. This plus 2 is not inside with the x. And on number 4, the exact same thing. That minus 2 is not on the inside of the x. Let's see what happens when I apply the plus 2 and minus 2 outside of the function. And again, you see here your original absolute value function. And notice what I've done again, the absolute value of x, and then I've applied the plus 2 outside of that. When I click on it, look what happens. Instead of moving it left or right, it actually took that function and it's identical. It just moved it up. And you can see the exact same thing happening when I add 4, when I add 5, when I add 6. It's moving it up by that amount. So going back, whenever I take the absolute value of x and I add 2, that's going to move your function up 2 units. And we kind of have an idea of what's going to happen when I subtract 2. And let's see if our idea is right. You see here again your absolute value function, and now when we subtract 2 outside of the function, it moves it down 2. And again, when I subtract 3, 4, or 5, it just moves it down by that amount. So therefore, by subtracting 2, I move my graph down 2 units. So this moves it down 2. So now let's try to apply that to a general function. Now let's see, does that exact same thing follow suit for maybe y equals x squared or y equals x to the third. So what I've done here is I've graphed your general y equals x squared graph. Now we know that the parent function y equals x squared is, we call it a parabola. Now what happens, and again notice with the different ones, and let me change and put the y equals with those. Okay, now you see the different functions, y equals x squared. Well, what happens, now this is the most important part of this. What happens when I add 2? Notice it's inside the function. It's in there with the x. I've got some grouping symbols around that x, and I put the +2 with it, or I put the -2 with it. Versus, notice here, I don't have anything around the x. I've got that +2 and -2 tacked on the end. When I take a function and inside with the x, I add a 2 to it, look, it takes your function and it moves it left 2 units. What happens when I subtract 2? It moves it right 2 units. So anytime you add or subtract inside a function to an x directly, okay, you've got the plus or minus directly attached to that x, it's going to move your graph left or right. But here's the thing, a +2 moves it left 2. A -2 moves it right 2. It moves it backwards from what you think it would. Now let's look at the other two scenarios. What happens when I take the whole function, not directly to the x, but I take my original function and I tack on a +2 or a -2 directly to the whole function and not just to the x. +2 moves it up 2, which is what you think it would do. +2 is up 2, -2 or -2 is down 2. So in general, let's go back to our worksheet. Let's scroll over to the side and let's talk about these different rules. Our translations. This is a guide that we can use. Anytime you take a function, now reminder of what f of x plus h means. If my function is something like x squared, and I ask you, what does f of x plus h do? Now, what you're doing is you're taking that x out and you're putting in x plus h. So that's saying that your plus h is being applied directly to the h. So f of x plus h, if it's a positive and it's applied directly to the h, that's going to move it left h units. If you do f of x minus h, again, the x now is applied a minus h directly to it. It moves it opposite. A negative would move it right h units. Well, what happens when you take the whole function? And again, f of x could be something like x squared. It could be something like the absolute value of x. What happens when you apply the plus k on the outside, not directly to the x? What happens when you apply it to the outside? It moves it either up or it moves it down. If it's a positive k, it's going to move it up k units. If it's a negative k, it's going to move it down k units. Okay, now let's talk about your next transformation. We now have what happens when you multiply by maybe a 2, or what happens when you multiply by 1/2. So let's go and check it. So you see here again, here's your original y equals absolute value of x. That's your parent function. Well, what happens again if I take and I multiply? Okay, we know pluses and minuses shifted it left, right, up, and down. What happens when I multiply by 2? And we click on it and we see. What actually happened was this point right here. Let's take a point. This point right here actually got pulled up to here. It's 2 times taller. This point here that used to be at 2, 2 is now up here at 2, 4. The point that used to be at 1, 1 is now at 1, 2. The point that used to be at negative 1, 1 is now at negative 1, 2. It's twice as tall. It stretched it. Now it stretched it in a vertical direction because again, notice where the number 2 is at. The number 2 is outside. It's not inside with the x, it's outside of the function. The function is that absolute value. If something is multiplied on the outside, like 2, it's going to stretch it vertically twice as tall. Now let's look at the other option to where, well, let's go ahead and write that down. That's 2 times vertical stretch. We'll put the x there next to it. 2 times vertical, because it was taller, stretch. Now what happens when you multiply it by 1/2? Okay, let's go and look. Your original function again is y equals absolute value of x. What happens when I put a 1/2 out front? Okay, what used to be located here is now half as tall as it used to be. What used to be at negative 4, 4 is now at negative 4, 2. So therefore, these points are now half as high as what they used to be. So this is called a vertical compression. Again, notice where the 1/2 is located. The 1/2 is outside of the absolute value bars. It's not inside with the x. So therefore, anytime that it's multiplied by 1/2, that'd be 1/2 times as tall. So that'd be called a vertical compression. We compressed it. We made it shorter. Now, these two that I'm about to show you are not on here, but I want to go through what happens when there's a 2 or a 1/2 inside. So I'm gonna add some extra problems. We can call it 8 and 9 if you would like to. But what happens when you have like f of x equals the absolute value of 2x? Or what happens when you have like f of x equals the absolute value of 1/2 x? Now these are going to look very, very similar to the graphs that we just did, but let's go over there and let's change our graph up to C. Okay, so we come over here and again we see our original graph, and notice where I put the 2 this time. I put it inside with that x right here. So what happens when I take and I multiply my x by 2? Now before we look at this, let's remind you that when I applied something like a plus or minus to my x a while ago, it shifted my graph left and right. When I applied it outside, it shifted it up and down. It applied it vertically. Just now, when I multiplied by 2 or multiplied by 1/2, it stretched and compressed it vertically. Now, when I multiply the inside, when I multiply straight to my x, when I multiply it by 2, click on it, look what happened. Now that looks a lot like my problem did a while ago, but I want you to think of it in a different way. This point here is now here. This point that used to be at negative 4, 4 is now at negative 2, 4. What happens when you multiply the x value by 2? It compresses it. It actually does backwards. Wait a minute, that sounds familiar. Remember what happened when I subtracted 2 from my x? It moved it right 2. What happened when I added? It moved it left 2. It was backwards. The same thing applies whenever you multiply the x by 2. This is going to compress horizontally, not times a factor of 2, but times a factor of the reciprocal, 1/2. It's going to be half as wide. Now let's look at the graph of y equals the absolute value of 1/2 x. Okay, here's your original graph, y equals absolute value of x. When you multiply the x value, when you're inside of the function and you multiply directly the x by 1/2, it got stretched. What used to be here is now here. It's twice as far out. What used to be here is now over here. What used to be here is now over here. So therefore, when you multiply the x by a factor of 1/2, it actually stretches it horizontally. So let's go back and let's write that down. So multiplying your x by a factor of 1/2 is going to stretch your graph horizontally, which means in the x direction. And that's the way I remember it. If the things are applied directly to the x, if the transformations are applied inside the function to the x, things happen horizontally. And they also happen backwards. So instead of multiplying by a factor of 1/2, you find the reciprocal of that. It's going to stretch it horizontally by a factor of 2. So let's apply that over here. So what happens, and these are called dilations, by the way. A dilation is a stretch or a shrink. What happens when you take your whole function and you multiply out front by a factor of a? Now, what happens when a is bigger than 1? When a is something like 2 or 3 or 4, that's when your stretch happens, okay? So that's going to be a vertical stretch, and it's going to be a stretch times a factor of a. Now, what happens when a is like a fraction, like a half or a fourth? That's going to be a vertical compression by a factor of a as well. So if it's like a 1/2 or a 1/4, it's going to stretch it by 1/2 or 1/4 or whatever that a value is. Now let's go ahead and add to it those extra two that I gave you. So here's those two scenarios. What happens when you go inside and you multiply your x times some factor? Now, if the factor is positive, or excuse me, bigger than 1, if the factor is something like 2 or 3 or 4, then that's going to be, again, if it's applied directly to the x, that would be a horizontal. Now, if it is you got to be careful here. If this is a number like 2, it's going to multiply by a factor of 1/2. So that would actually compress. Um, anything bigger than 1 is actually going to compress it horizontally, and it's going to compress it by a factor of 1 over a. So you do have to flip it. And the same thing happens over here. What happens if your a value is like 1/2? Well, that's actually going to it's going to stretch it. That's going to be a horizontal stretch by a factor of, again, you have to flip it when it's inside with the a, or when it's inside with the x. Okay, let's talk about the last scenario. What happens when you put a negative sign on it? So let's go back in our original function, y equals absolute value of x. Let's apply a negative on the outside. And again, of course, I'm going to add a new one. And we had 8 and 9 down there, so I guess we can call it 10. I also want to look at what happens when you apply the negative to the x. I'm not sure why these got left off, but I like to include them. So let's take a look at this graph. So again, here's your graph, y equals absolute value of x, and notice what we've done now. What happens to our graph when we put a negative out front? Now we know pluses and minuses shifted or translated our graph left, right, up, and down. Multiplication, we found out, is going to either stretch or compress our graph. And anytime we apply a negative, it flips the graph. So what used to be up top is now down bottom. It flipped it across the x-axis. Let's talk about vertical versus horizontal. Our original graph was up top. It flipped it up to down. When you put the negative on the outside, again, not directly to the x, when the negative is applied to the outside, it's going to flip it vertically across the x-axis. It's going to flip it from up to down. So therefore, this is going to be called, we're going to call it a vertical flip. So you might already have an idea of what happens when we put the x or the negative on the x. So again, let's go to our graph. Here was our original parent function, but notice what I've done here. I've took and I put the negative, I applied it directly to the x. When I put it out front, my graph flipped up to down. It flipped across the x-axis. When I apply it to the x, and I click on it, it didn't look like anything happened, but it did. It flipped across the y-axis. So pretty much what used to be here is now over here. What used to be over here is now over here. Since this thing has symmetry, it doesn't look like it changed. However, that would be a horizontal flip across the y-axis. So let's write that down. So anytime you apply a negative to the x, that would flip your graph horizontally. So that'd be a horizontal flip. And you can put, if you would like to, that'd be across the y-axis. So a vertical flip over here would flip it across the x-axis. So let's go over and let's apply that now to our guide. So if a negative is applied to the outside of a function, this would be a vertical flip. And that would be across the y-axis. Let's go ahead and add on the other scenario. What if you do f of negative x? That would be when the negative is placed directly onto the x, this would be a horizontal flip. And that would be across, well, This would be across the x-axis, my bad. The horizontal flip across the y-axis. So there you see all the different scenarios, and what I would like to do in closing is I'd like to go through and take another parent function and go through each of these transformations to remind you what each of them do. So I'm going to use y equals the square root of x. And just as a reminder, okay, what if you take the square root of x and directly to the x you add 3? That's going to move your graph left 3. Again, remember that if it's applied inside the function, pluses move it left, minuses move it right. So therefore, what happens when I change that to a minus 3? It takes your graph and it moves it to the right 3, backwards. Inside with the x is backwards. Okay, next up, what happens when I take the whole function and not inside with the x, but on the outside, I add 3 or I subtract 3. Plus 3 would move it up 3. And then finally, a minus 3 would move it down 3. And that's all your translations. Then we talked about what happens when you multiply by values. If you take your entire function on the outside of it, you multiply by 3. That's going to make it 3 times taller. Every point got moved up 3 times from where it was. What happens when you take a fraction? Like, let's do 2/3. What happens if you take a fraction like 2/3 and you multiply it by your function? It makes it 2/3 as tall. So the point that used to be here is now located here. 2/3 as tall as what it used to be. Now let's travel on the inside of the function. Let's multiply the x. Okay, what happens when you multiply it by something? Let me take that graph off. What happens when you multiply your x by a number like 5? You would think it would stretch it, but it doesn't. It actually does backwards. The same thing the plus and minuses did it backwards. If you multiply by 5, it's not going to stretch it horizontally by 5. It's going to stretch it horizontally or compress it by 1/2. So what that does is what used to be here is now 1/5 of the way back here. What used to be here at 4 is now at 1/5 of that, which is 4/5. Okay. So, a 5 is going to compress it horizontally by 1/5. What happens when you apply a number like a fraction that is less than 1? Okay, let's do a value like 2/3. What happens when I take my x and I multiply it by a factor like 2/3? Reciprocate that, and your function actually gets stretched by a factor of 3/2. We know that the reciprocal of 2/3 is 3/2. So what used to be here is now 1.5 times as far out here. Take this x value, multiply it by, take that x value, multiply it by 3/2, and you get an x value that's out here. And then finally, we took, and in our last phase, we multiplied by negatives. We put negative signs. When we took and we put a negative out front, it took our graph and it flipped it up and down. It flipped it from the top down to the bottom. If we take a negative and we put it on the inside with the x, and again, anything that's applied to the x is going to happen horizontally. It takes my graph and it flips it left to right across the y-axis. And that is every transformation that you're going to be dealing with in this class.